Hey guys, welcome back to another binary search video where this time we're finding the square root of a hidden value x. Well, we're given a non-negative integer x returned to the square root of x rounded down to the nearest integer. The returned integer should be a non-negative as well. We cannot use any built-in exponent functions or operators. For our video, we're going to be using Python. If you want to follow along, then open Leetcode problem 69, square root of x. If you're not familiar with binary search fundamentals and how it iterates, this is not the first video for you. This is a video to refine your skills in binary search. If you want to learn the fundamentals in binary search, I recommend the video which I'll have linked in the description below or possibly in a playlist to your right. So what is this question asking us? So given a non-negative integer, in other words, a positive value, return the square root of that value, x, rounded down to the nearest integer. So we're given a value and we need to find the square root of that value. And if the value is in a decimal, we need to round it down to a nearest whole number. The returned integer should be non-negative. So we can't work with negative numbers. We're only working with positive. So if you don't like visual examples, I'm going to put timestamps in the description where you can skip over and go right to the code. But I like to do visual examples. That's how I learn. I'm sure there's other people in the world who are like that. And I'm going to continue onwards with it. So let's say that that hidden value is x equal to 9. And we know that since we're working only with positive values, that it's going to start at 0. Because it can't be negative 1, because that's a negative number. So 0 up to 9. And with binary search, we're always starting at the middle index. So that's going to be 4. And how we're doing this with binary search, I'm going to explain the code afterwards, and I'm going to do the visual example first. Don't worry if you're not fully following along with the steps. We're going to take 4 squared, and we're going to get that value, which is 16. So 4 squared is the same as 4 times 4. So we have the value of 16 now, the middle value of 16, and we need to compare it to x. So is 16 greater than or less than or equal to 9? We know 16 is greater than 9. So everything after this middle index can be crossed out because we know everything after this point is only going to be bigger than. For example, 5 squared is going to be 25. It's only going to get bigger. There's no point of searching it. We can cross that out. So that leaves us with the array size of 0 to 3. We need to move our endpoint to 3 because remember the endpoint is always mid subtract 1 and our start point stays the same of 0. And now we have to get the new midpoint, which is 1. So we have 1 squared equal to 1, as you guys know. And is 1 less than or equal to 9? We know it's less than, so we continue moving to the right. And binary search, you never move to the left for this type of scenario. You're always moving to the right. So x0 can be crossed out, so we can move to our new starting point of 2. And our new array size of 2 and 3. Let me square it. Let me make a square around it so that way it's just a little more visually clean. And we need to get the new middle point. And as you guys know, since it's only 2 indexes, the middle point is going to be the first. So 2 squared is equal to 4. 4 is less than or equal to 9. It's less than. So it's true, and we continue. Continue to the right. Now we have 3. 3 squared is equal to 9, and we found our value. Not only did we find our value, the way that this code works is that it takes the last value of the iteration and it assigns it for imperfect squares. For example, x equals 12 doesn't have a perfect square. That'll be 3.46, I think. It'll be about 3.46. You need to put that to a correct value because 3 squared is equal to 9. There's no squared value that's gonna get you 12 because 4 squared, which is the next value after 3, is gonna be 16. There's nothing in between besides decimals. And the question is asking us to round down to the nearest integer, which is going to be 3. So the way that this code is going to work is it's going to get us the last value to the right that the iteration gets us. So we're going to start equals 0. Remember, we're only doing positive values, and end is equal to x. Start is equal to 0, and end is equal to x. X is an unknown value for our Leetcode problem. While star is less than or equal to end, middle value is equal to start plus end divided to the floor of 2. And then we want to get our squared value. So square value is equal to mid value times mid value. So remember, squaring is the same as 4 squared, 4 times 4. Now, if squared value is less than or equal to x, then answer, or whatever variable you're comfortable with, if you don't understand the code yet, just put answer. Answer is equal to middle value. Start is equal to mid plus 1, because remember, we're always moving to the right. Else, we guessed too high, and we need to move our end value. Mid, subtract 1, and we need to return that answer. So remember, we're always moving to the right, and that answer is storing the last key that we got. So we're always moving to the right if it's less than, and it's getting the last that we got. Because remember, if it's x equals 12, the answer should be 3, because we need to round down, not 3.46. That'll be incorrect. And it can't be 4 because 4 is 16. I'm going to run the code. That's because this error, so hopefully someone caught this while I was typing this. And if you think you can catch it, pause the video and say why. Otherwise, I'll correct it right now. So I put star equals mid plus 1 when the variable is mid-val. Let me run the code again. We see it's accepted with these two test cases. X is 4 and the output is 2, because the square root of 4 is 2, and 2 times 2 is equal to 4. Test case 2, x equals 8, and the square root of 8 is not a possibility, but the clearest we can get is 2. That's the closest we can get rounded down to the nearest integer. Otherwise, it'd be a decimal point. I'm going to submit the code so that way we can make sure we pass all test cases. We see the code beats 24.70% of users. Other users, you don't always have to go by runtime comparisons, and memory beat 80% of users. This is because under the Leetcode description, it says you can't use x to the exponent of 0.5 in Python. A lot of people submitted their answers with x to the exponent of Python. Leetcode will not block you from breaking the rules. They let you submit answers. The point of Leetcode is for you to learn and not essentially quote unquote cheat. So guys, do it on binary search. This is a binary search problem. Ignore the runtimes and comparisons with other people. If you look at the submissions of other users and the acceptance rates, you're going to see why. And if you look at the discussion board, you're also going to see that people were using built-in functions when they weren't supposed to. All right, hopefully this video helped. Otherwise, again, guys, spaced repetition, keep doing the code, keep trying to understand it, and you'll get it.